Hello again, geometry class. We're ready for our next video lesson. Today we are moving on into section 4.2, congruence and triangles. There is a lot of review that's going to get mixed in today. First of all, I want to review just kind of notation with you. At the top here, review. If you have AB with the bar on top, they are talking about a segment, and segments are congruent. An AB without the bar on top is referring to the measurement of AB. Measurements are equal. Same thing happens with the angles. If you have the angle A, then it's referring to the actual object itself, and angles are congruent. But if you do the measure of angle A, they put that little M in front, then we're talking about the measure of angle A. Measures are equal. So very subtle differences do mean different things, so please be aware of that. Next up, we've kind of talked about this before, but to prove whole triangles are congruent, you would need 3 congruent angles and 3 congruent sides. Once you have met all 6 criteria, 3 plus 3 is 6, then you can write these fancy things called a congruent statement. Now, a congruent statement says one thing is congruent to another, statement of congruence. All the congruent parts need to match up in the specific order. So it's kind of like a little matching game when you set them up. We have one new little theorem today, which is the third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles will be congruent. You don't actually have to prove them. So if you've got 2 given, the third angle pair will match up. Now, properties of congruent triangles. These are going to look familiar to you. Reflexive, symmetric, and transitive. We have used them with segments. We have used them with angles. They also work for triangles. And they work out exactly the same way. Reflexive, let's say we have triangle ABC. Well, reflexive means it's congruent to itself. Triangle ABC. Okay, reflexive, you have the same thing on both sides. Symmetric, if I have, let's say, triangle ABC congruent to triangle XYZ, then by the symmetric property, flip the 2 triangles around. Triangle XYZ first would be congruent to triangle ABC in that second and last position. And our transitive property, this one's a little longer, if triangle DEF was congruent to triangle GHI, and we knew triangle GHI was congruent to triangle JKL, then triangle DEF, the first one, would be congruent to triangle JKL, the last one. And all 3 are going to work as properties of congruence, so you should be throwing that POC on the back end of them if you use them for a reason. All right, so not a whole bunch new, a lot of reviews in there, and it's a lot of matching today. Looking at our first example down here at the bottom, example 1 wants you to identify any figures that can be proved congruent and explain your reasoning and write a congruent statement when possible. So there's a lot going on here. Well, first of all, look at all the given parts in the triangle. I'm noticing At the top here, angle C is 20 degrees, angle Q is 20 degrees. So angle C is congruent to angle Q. Angles are objects. And really, it's because they have the same measure. And that was actually given to us. Also, angle E is 20, angle P is 120. So angle E is congruent to angle P. And again, they were given the same measurements. Okay, given. Well, if I have two pairs of angles that I know are congruent, then the third angle down here, we'll give them 3 marks there so they match. That third angle is also congruent. Now, I can't call it angle D because there's a lot going on at point D, so you got to be more specific here. I'm going to say angle CDE. Okay, that's the one on the left. Is congruent to angle, let's say QDP. Now, this is a new one. This is our third angles theorem. We were given 2 angles congruent. The third pair is by the third angles theorem. Okay, that's one of our new ones today. So we definitely know all 3 angles are congruent, which is good. And I'm pretty sure that we can say all 3 sides are congruent as well. With the little 1 marker on it here, segment CE is congruent over on the right picture with the 1 congruent marker. Let's call that PQ. Ooh, let me get that crazy line out of there. There we go. PQ, because that was given. It's marked congruent already for us. This bottom side over here on the left with the 2 markers, segment ED, is congruent to the 2 segments on the right, DP, and again, that is mark given. And the third side, 1, 2, 3 markers, CD on the left, is congruent with the segment with 1, 2, 3 markers, DQ on the right. All 3 sides were already marked congruent. That is given. So we've got all 3 angles, all 3 sides, which means that the triangles are also congruent. Now, we need to write a congruent statement, which is going to say that one of the triangles is congruent to the other triangle. But we have to be really specific with our letters. They need to match up. So name a triangle, any triangle. I'm going to name the one on the left angle CED. Okay, the first one you can name however you want. But it's the second one you have to be very careful with your matching parts. If I start with the letter C, well, C, angle C here, is congruent to angle Q. So my congruent statement will start with Q. My middle letter is E. E was 120 degrees. P was 120 degrees. So P is my next letter. And then we meet at D in the middle. So D will be my last letter. Triangle CED is congruent to triangle QPD. Congruent statements, again, you need to have all of your angles, segments, etc. match up. Be very careful with that. Now, because those congruent statements are so matchy-matchy, that can help you find missing measurements. Flip over to the back side here. Example 2. Now we have really quadrilaterals. They have 4 sides. We really don't know anything other than that. But our congruent statement says a quadrilateral, we'll say quad here, ABCD is congruent to KJHL. They are using all 4 corners to help you out. Remember, this is a congruent statement, so the parts are matching. They would like us to find X. In my picture, kind of look for it, X is over here on the right-hand figure, and it's matching on segment KJ. Now, this is where we're going to use our congruent statement. KJ was the first two letters up there. So that means they'll match with the other two first letters, AB. So on my diagram, I know that I am matching with AB. They are congruent segments. Congruent statement, congruent segments. So I know that 4x minus 3 is equal to 9. And then I have to solve. So I'm going to add 3 to the right, which gives me 4x equal to 12. And if I divide by 4, x is 3. There is my first missing variable. We need to do the same thing to find y. Now y, search for it in your picture, y is over here at angle H. Okay. Now, angle H, let's go to our congruent statement. H is that third letter, which means that it is congruent with the other third letter, angle C. Well, we know that angle C is 113 degrees. Those angles are congruent, so 5y minus 12 is equal to 113. I add 12 to the right. I have 5y equal to 125. If I divide by 5, y is going to equal 25. It's all about matching your parts up, and your congruent statement, well, that's going to tell you exactly what parts match with other parts. All right, let's use this a little bit more down here. Example 3, we're still going to match a lot of pieces up. We need to use our given information to find the indicated value. Well, we have angle A is 20 degrees, and if you look at the other triangle, it has a matching angle mark with E, so I know E is also 22 degrees. Okay, they're, again, have matching congruent angle marks. Angle B is marked as 87 degrees. It has a matching congruent symbol with G, so I know that is also 87 degrees. And then the third angles, angle C and angle F, are going to be congruent. And F has the x in it. That is the value that we would like to solve for. Well, since we've transitioned all of our measures from one triangle into the other, we do have all three measurements, E, G, and F, in our right triangle, the one on the right-hand side. All three corners of a triangle always add up to 180 degrees. So our 22 plus 87 plus 4x minus 15 will all add up to 180. So we get a big math problem. Well, if I combine like terms here, let me break out my calculator. 22 plus 87 minus the 15, we will have our 4x and 94 equal to 180. We subtract 94 to the right, we get 4x equals, I do it on my calculator real fast, 180 minus 94 is 86, and if I divide by 4, I get 21.5. You may get some decimals tonight. All right, just like a normal day, I goofed in there, didn't I? It's like I'm really there, right? Let's see. This should have been a plus 15. Aha, and maybe we won't have decimals. If I erase, let's make my eraser bigger because that's going to take too long. All right, so, do you like my sound effects? Okay, 22 plus 87 plus 15. That's going to be a little bit different. 22 plus 87 plus 15 is 124. So 4x and a positive 124 is equal to 180. Minus 124, we have 4x equal to 56. And if we divide that by 4, aha, x is